Okay, so in this video, I'm going to talk a little bit about the Pythagorean theorem. This thing. So if you remember just some vocab real quick, for every right triangle, you have two legs, okay? And the legs are the thing that are around the right angle. So if you look at the different diagrams here, right, you can see like here, there are these ones. On this one, it's this one. On this triangle, it's this one. It's whatever is around the two or the two segments hitting up to the right angle. The other length is called the hypotenuse. Okay, again, hopefully this is review for you. A lot of times we see labels on these. So these are A and B, okay, and the hypotenuse is C. The legs are interchangeable. Like it doesn't matter if this is A and this is B, or if this one is A and this one is B. Like those don't matter, just as long as the hypotenuse is always C, okay? If you remember, when we have a right triangle, okay, what the Pythagorean theorem says is if you were to draw a square off of each of the sides, so we'll pretend like that's a perfect square, pretend like this is a square, and pretend like this is a square. The area of this, so this is A squared, the area of this, B squared, and the area of this, C squared. Your A squared plus your B squared is equal to your C squared, okay? So I'm not gonna do a ton of examples with this. Let's do a couple here though. So let's say that like we have a triangle here, okay? And these, let's actually just use the graph paper here since it's there here. So this is 1, 2, 3, I'm just counting out my squares here. So 1, 2, 3, 4, 5, 6. Okay, so we'll do 6 here. Okay, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, oops, let me write that in pen. 9 here. And so what we want to figure out is what is this number here. Okay, so what we're going to do is we're going to take 6 and we're going to square it. Okay. And then we're going to do plus 9, and we're going to square that. And that's going to give us this side, the C squared, okay? If you want to draw squares off of it, okay, you can. So you could draw a square here, and you could draw a square here, and you would, right, if you counted each of these, you would see this is 36, okay? 6 squared is 36. 9 times 9 is 81, okay? So this is 81. Okay, is equal to C squared, okay? So then I am going to pop over into a calculator, and I'm going to do, well, actually, I can do this in my head. 36 plus 81 is going to be 6 plus 1 is 7. 3 plus 8 is 11. Yes, okay, that's equal to C squared, okay? So if you look at this, 117 is not a perfect square. So what we have to do to get rid of that C squared is we're gonna do the square root of each side. So I'm gonna go square root of C squared, square root of 117, okay? This is impossible to do in your head. Okay, you could approximate about what it is, but at this point you're gonna get a calculator. What I recommend is going to Desmos.com, and they have a calculator built in to their website. So if you go to Desmos.com and you click on Start Graphing, there's a calculator built in there. Oh, you know what? Sorry, that's actually bad advice. Don't go to Start Graphing. You're gonna go to press the scientific button. Okay, so you click on that, and then in there I'm gonna do square root of 117. Sorry, I can't show this to you. And that says that C is I'm gonna round here because it's an irrational number, so it goes on forever, and it's 10.82. Okay, 10.82. So I took the square root of that number, and that gives me that. So that means this side here, this is the square root of 117, okay, which is the exact answer, or, yeah, I'm just making that worse, or you can say that it's approximately 10.82, okay? So that's how you do the Pythagorean theorem. If you need more help than this, like if this is not enough information to remind you how to do it, you are gonna have to do a little bit of Googling, okay? Let me show you one more thing that you're gonna see in these practice problems. So if I'm gonna do graph paper again for my background. Sometimes you'll see on this, it'll give you like a diagonal. So it'll be like, hey, let me zoom in here. It'll say, hey, I have a segment that goes from here to here, okay? And I want you to tell me how long this segment is, okay? It's not possible to measure it or count it because it doesn't line up with the graph paper behind it. So for these ones, what you do is you basically are going to create legs. Okay, we're going to pretend like this is the hypotenuse of a right triangle. So I'm going to create leg 1, leg 2, and I'm using my graph paper to create a right triangle, okay? Because now it's super straightforward. I can say, hey, this is 2, okay? This is 1, 2, 3, 4, 5, so 5 across there, okay? And then now I can just do the Pythagorean theorem. So let's go ahead and do that, okay? So I'm going to go to 2 squared. Oop. 2 squared plus 5 squared equals c squared, okay? 2 squared is 4. Oop, wrong one there. Plus 25 is equal to c squared. So 4 and 25 is 29 is equal to c squared. So that means that c is equal to the square root of 29. Okay, so you can actually just write on here square root of 29 if you want to. Sometimes it'll tell you to round it. So in that case, you're gonna find a calculator online or on your phone, and you're gonna, if you put 29 in there, you're gonna get 5.4 approximately. Okay, 5.4. So if you remember back to the irrational lesson that we did in the other day, with a square root thing, right? You could say, hey, square root of 29 is between 5 and 6, okay? Because it's between square root of 25 and square root of 36. Okay, that's a quick thing on the Pythagorean theorem. See if you can do the practice problems on the next page, and email me or let me know if you have any questions.